Well, hello, everyone. My name is Mia. I work with Neil Blair, and my project is focused on terrestrial river systems and floodplain sediments and trying to understand the dynamics of the terrestrial carbon cycle and the influences of human land use on those dynamics. So it's well known that human land use has affected sedimentation rates and organic carbon cycling on terrestrial landscapes. This study just came out in 2020. It's really kind of unsettling. Since European settlement in North America, we've seen a tenfold increase in sediment accumulation rates on river systems. This is also corresponding with an increase in agricultural area, probably highlighting that human land use is affecting this change. And we know that superficial erosion coming off of runoff from agricultural areas is one of the biggest influences in the retention of organic carbon in river systems. So the idea is, where is the extra sediment going and what's the organic carbon story behind this? And my hypothesis is that a lot of this organic carbon and sediment is just ending up in floodplains in agriculturally dominated landscapes. And so this is my floodplain. It is in, oh, sorry about the farmland thing. It's in central Illinois. The picture is on the left. You can see that it's very heavily forested. So it's actually a riparian forest that's been undisturbed for over 200 years. And it's completely surrounded by farmland. So it's actually a beautiful, beautiful natural laboratory for my study, because you have the huge human influence coming off superficial erosion runoff from agricultural areas. And that sediment is all getting trapped into the river system because it's a relatively topographical low. I mean, we're in the Midwest, so microtopography is like really important. And then the sediment coming out of the river when the river floods is also getting trapped in the floodplain because of the vegetation. So this is a sediment core that I got. We've been having some trouble with coring. I just got them this summer because, surprise, surprise, plains flood. And so it's like really hard to get cores sometimes, especially in the summer. So more to come on that. Don't have any data, unfortunately, for you. But I will tell you a little bit about what I'm going to do. I'm taking a threefold experimental approach to try to understand the spatial dynamics of the organic carbon cycle on land in the Midwest in these agriculturally dominant landscapes. The first thing that I plan on doing is trying to identify where the organic carbon is coming from by using organic biomarkers. I'm happy to answer questions about that afterwards. And so this is kind of like a geochemical understanding. What is in the sediment archive? Where is this organic carbon coming from? Is it agricultural? Is it coming from terrestrial vegetation? Like, is that vegetation, does it have like a corn signal? Things like that. The temporal understanding comes from this idea of using a technique to highlight radiocarbon offset, which is basically the difference between the age of the organic carbon fraction in sediment and the age of deposition. And so, for example, if you have some like really anomalously old ages at like buried, I don't know, 20 centimeters depth, that's not what you expect. And that basically might indicate that that material is not just like super old and there's a mistake, but rather that it has been remobilized from being previously buried upstream, indicating more fluvial erosion, like the water cutting into the banks. Overall, this will hopefully give me a better understanding of like what's in a sediment archive in floodplains, which is actually kind of a lacking corner of the literature on river systems. And then also, how does it get there? And hopefully we'll highlight some further future directions in identifying human land use and how it's affecting these systems. So